Hi, my name is John Paul Raj, and my mission in life is to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this video, we are going to talk about limits, a very basic idea of the definition of limits using a graphical approach. Let's start. A limit is the y value a function approaches from both the left and the right hand side of a given x value. That's the simplest basic idea of what a limit of a function is. A limit is the y value a function approaches. That doesn't mean that is equal to, okay? So that's a very important word, approaches from both the sides, from both the left hand side and the right hand side of a given x value. Now let's illustrate this basic definition using some examples, all right? So this is a function here, the graph of a function given to you. The question is to find out f of -3. So when you just find the value of the function, basically we just go along vertically and you read it off the y-axis and say, okay, that must be 4. F of -3 is 4. But limit as x approaches, that arrow means x approaches a -3, okay? So limit as x approaches a -3 would mean, as the definition says, the y value a function approaches. So y value, what y value is it approaching? It's from the left-hand side and from the right-hand side, okay? From the left-hand side and the right-hand side, the y value that the function is approaching is also, in this case, 4. So in this case, we have the value of the function and the value of the limit of the function at that point, limiting value x approaching -3, the same. And let's take a look at the other example. Look at the example first, okay? What do we have? At -3, the value of the function at -3, f of -3. What's happening at -3? If we drop that line again and we see that there is a hole. There's a hole, it is not defined. So we write it as does not exist or not defined. So f of -3 is not defined. But the limit of the function as x approaches -3, okay? X is approaching -3 from both sides, the left-hand side and the right-hand side. The value of the function from the left-hand side and the right-hand side approaches 4. Still approaches 4. It's not equal to 4, approaches 4. And that is the definition of the limit, that the y value that the function approaches, you see that word? That word is important. Approaches doesn't have to be equal. So in this case, the function is not defined at x equals -3, but as x approaches -3, the function has a limit and it's equal to 4, okay? Third example, third graph, okay? What's happening at x equals -3? Watch, okay? At x equals -3, the value of the function, it's not defined along there. There's a hole there, but it's defined at that point and it's defined to be 1. So the value of the function is 1. F of -3 is 1. The value of the limit, remember what's the definition? As x approaches -3 from both sides, left-hand side and right-hand side, what's happening? The value of the function is approaching 4 again. It's approaching the same value from both ends. So the limit exists and the value of the limit is 4. So in this case, f of -3 is 1, but the value of the limit as x approaches -3 is 4. So if you compare all the 3 examples, okay, the graphs look very same, but what's different? Let's look at the differences. In the first example, we saw function value at x equals -3 and the value of the limit as x approaches -3, both were the same. Can you see that? They both were 4, all right? It's defined and it's equal. The second example we saw was when the function value at x equals -3 was not defined. It was not defined. It did not exist. There was a hole. But the limit as x approaches -3 exists and it was equal to 4. And the third example, which we just saw, was the value of the function and the value of the limit were different. Let's look at the definition again, okay? What is a limit? A limit is the y value a function approaches from both the left and the right-hand side of a given x value. A y value a function approaches, that clearly means that the value of the function is not the same thing as the value of the limit of the function at that limiting value. We've taken 3 examples to illustrate that. Okay, fourth example. This is a different function this time. It's a piecewise function, f of -3. So if you look at the value of the function, we've got 2 pieces. The value of the function is from the second piece, okay? So you can see that it's defined to be 1. So f of -3 exists and it's equal to -1. Second piece, the first piece looks like a hole there, but it's actually defined at the second piece. Now, limit of the function as x approaches -3. Remember, according to your definition, we need to check what's happening from the left-hand side of -3 and from the right-hand side. So x approaching -3 from the left-hand side, the values of the function seem to be approaching 4. So I'm going to write LHL, left-hand limit is 4, which means as x approaches 3 from the left-hand side, x values are increasing, the y values seem to be increasing, and almost approaching 4. So left-hand limit is 4. The right-hand limit in the same way, as you're approaching x is equal to -3 from the right-hand side, that means values of x are decreasing to -3, approaching -3 from the right-hand side. The values of the function are coming down and decreasing, and they're approaching 1. So I have a right-hand limit equal to 1. Look at this case. It's an interesting case. The right-hand limit apparently is equal to the value of the function, and the left-hand limit is different from the right-hand limit. In all the examples we saw before, the left-hand limit and the right-hand limit were the same. They were approaching the same value. And our definition says that a limit is the y value a function approaches from both the left-hand side and the right-hand side of a given x value. So in this case, because the left-hand limit and the right-hand limit are not the same, we will say that there is no limit. In fact, the limit does not exist. So this is a case where the function is defined. The function has a value at x is equal to -3. But the limit is not defined because the left-hand limit and the right-hand limit are not the same. Example 5. Again, a piecewise function, but let's look at what's different in this example. F at -3. At x is equal to -3. Okay, at x is equal to -3, both from the right-hand side and from the left-hand side, both those pieces seem to have holes there, but the function is defined to be 2. So the value of the function exists, but it's equal to 2. It's neither from those two pieces. Now let's look at the limit of the function as x approaches -3. Now first from the left-hand side, as x approaches -3 from the left-hand side, as you can see, the value of the function approaches 4. So the left-hand limit, again, is equal to 4. The right-hand limit, as x approaches -3 from the right-hand side, it's coming here, and the value of the function is 1. So RHL, the right-hand limit, is equal to 1. This is an entirely different case. Here, the value of the function is different. At x is equal to -3. The value of the left-hand limit is different. The value of the right-hand limit is different. And the limit of the function as x approaches -3 does not exist because the left-hand limit and the right-hand limit are not equal. So let's review the examples we've seen so far. In the first example, the value of the function was equal to the value of the limit. Both of them was equal to 4. Okay. In the second example, we had the function was not defined at x equals -3. Okay, because there was a hole there. The function had a limit as x approaches -3, and it was approaching the same value from both sides. Okay, and therefore we said the limit existed. In the third example, the value of the function was 1, and the value of the limit of the function as x approaches -3 was different. Both existed, but both are different, but the limit still existed. In the fourth example, the value of the function was equal to the value of the right-hand limit, but that doesn't make much of a difference because the limits has got nothing to do with the value of the function. Both the left-hand limit and the right-hand limit must be equal. In this case, left-hand limit was not equal to the right-hand limit, and therefore we concluded that the limit does not exist. Okay? And in the fifth example that we saw, the value of the function, the value of the left-hand limit, and the value of the right-hand limit, all three were different. But the limit of the function has got nothing to do with the value of the function. The limit does not exist because the left-hand limit and the right-hand limit are not equal. So the limit of a function is the y value a function approaches from both the left-hand side and the right-hand side of a given x value. In the next video, we're going to talk about one-sided limits. See you there.